So today I'll talk about Hawkular Metrics. It's a metric storage and alerting engine. Everybody had a slide that talked about themselves. I will tell you something about myself through the eye of somebody else. So this is what my daughter came to me about a few weeks ago. Says, Daddy, I made a figurine of you. And you have to pay attention to the details. First, it's all blue, so I like color blue. And then there is the laptop there, so probably she sees me walking around with this in the house. So, and of course the facial hair is all there, so that summarizes me. I'm the co-creator of Hawkular Metrics, and I've been working at RedHat for about 6 years now. This is a presentation about Hawkular Metrics. So I'm going to tell you what Hawkular is. We'll delve into Hawkular Metrics and alerting, and then there is the demo. And if you have questions along the way, just ask me. You will see me panicking, trying to find an answer sometimes, but just feel free to ask questions. We cannot talk about Hawkular unless we talk about the prehistory. Red Hat acquired JBoss around 2006, and that's when they started a project called JBoss Operations Network to manage the EAP servers in production. That's the logo of the product, and the idea is you have a bunch of dispersed servers, and then you centralize the management. Version 1.0 was started in 2006, and then 2008, there was a fork from another product and became Project RHQ, and that became the foundation for JBoss Operations Network. And this project lasted for, it's still the RHQ project is still right now a community, and it's a smaller community than it used to be in the past, but the project is still alive. So up until 2016, there was active commitment to the project, and there is still some commitment. One of the problems with this project RHQ, most of the stuff that you see, this is a screenshot of what you can do with it. It's overwhelming. It has a lot of stuff that you can do just to manage servers, machines, and then EAP servers inside of those machines. Most of the stuff that you see here is reactive. You go in and you actively do something. There is only one feature here that is passive, and that's the metrics collection that you see right here. So for example, the server has been up this entire time, and then you can see the various metrics that got collected here for this server. So most of it is passive, is not intensive, but then when you go to, it's passive because you only go and do a certain operation, but there is an active component to this which is constantly collecting metrics. So in 2012, we went through a set of performance optimizations, and this came as the #1 performance problems. You couldn't collect more than, I think, 10,000 metrics per second. And there were users that had millions of these EAP servers in production. So we started looking into what can we do to speed just this one portion, right? Collecting metrics and then displaying the metrics. And in 2012, time series was not around. We looked around to see if there is another storage that can do that for us. Just let's have a separate storage and put all those metrics there we couldn't find. Up until that point, everything was stored in Postgres. And we said, well, maybe we can do it better with Postgres. So we tried a few things, nothing worked. And around 2012, we said, well, why don't we go with a Cassandra-based solution? And the decision was not immediate. We went through a very long process of deciding what's the good storage for Project RHQ and for what we are doing at that point in time. And that's when the RHQ storage node came about. And it was very simple. It's a Cassandra-based cluster. The users don't need to know about the storage node. Metrics come in, metrics go out. That's all what there is, nothing more complicated. And we got a lot of feedback. A lot of people liked what we were doing, and we said, well, we cannot add features because this is specifically designed for this ginormous application. But why don't we fork this? Why don't we fork the original code and do another RHQ project? And that was RHQ metrics. We are going to add features that we would normally not add in RHQ. And RHQ was very rigid in terms of requirements. It has a specific type of aggregation, and it was expecting metrics at certain intervals, 30 seconds. And we said, well, forget about all that. I cannot all of a sudden go and force this huge application to accept metrics every second. So we said, we are going to create another project underneath the RHQ umbrella, and then we'll continue our work. Well, that is around 2014. That is when Hawkular got invented. So the name comes from a hawk, because it's a very good, bird, sharp vision, good hunters, and they anticipate the movement of the prey. So us as engineers said, well, we like the hawk, but we want it to be better. So why don't we stick a monocular on the hawk? So we have a cyborg now, and we call it Hawkular. So the goal of the project and the organization is to be able to monitor and catch anomalies in a fast-moving environment. And under this umbrella, there are a lot of projects. And today I'm just going to touch on Hawkular Metrics. That's the bulk of the presentation, and then a little bit on alerting. All the projects under the organization are Apache licensed too. I cannot predict the future. That's why I put the star there. So now we are going from prehistory to history. And what's interesting about this prehistory, if we are going to ask the same question today, what can we do to better store and display those metrics, there are answers today. So just a difference of like 4 years, I wouldn't have been in this space. I'm lucky that I'm in this space because we asked the question way too early when nobody was doing anything. So it's just a pure luck. And I've been doing this since 2012, so I have 5 years of just pure metrics. So 2014, the Hawkular organization got formed. And in 2014, Hawkular was one of the initial projects Hawkular Alerting was one of the initial projects that got in. Metrics was not part of the original Hawkular because Metrics was still under the RHQ umbrella. And in 2015, we joined. We said, well, alerting is there. There are some other components. Why don't we join? Hawkular has a better mission for us rather than being under RHQ. And here is a very critical point in the history of Hawkular Metrics. In 2015, we got integrated with OpenShift Origin. So when you use OpenShift Origin and soon online, you will hit Hawkular Metrics. So if you have questions about the scale, it's in production, has been in production for a few years in heavy loads. And in 2016, up until 2016, if you wanted metrics and alerting, you had to install and configure two products and then make them talk together. And we said, nah, that's too complicated. Why don't we do something better? So we integrated both of those into one single deliverable. So 6-7 months ago, now you can get one single binary deliverable, and you have both of those integrated. And I'll go into what that integration is. So Hawkular Metrics is a storage engine for metric data. It's not a time series database. I try to stay away from that because we approach this from an operational standpoint. We are interested in measurements taken at a specific time in the context of operations management. And we want, the goal is to store those metrics as efficiently as possible for their useful lifetime. Storing metrics for 1 year might not be useful. And storing metrics for 1 year and not being able to query them, that's not useful either. So its efficiency is important to us. There are 4 types of metrics that are supported. You have the gauge, and it's a number that can vary. Here I just have an example with the memory usage. And then we do allow users to compute rate of change. So how fast is my memory usage changing? The next one is a counter, is an integer. And the idea with this is monotonic, increasing or decreasing. And we make a distinction between those because of that rate of change. The rate of change for a gauge has a little bit of a different meaning than a rate of change for a counter. In a counter, you are never going to lose the total number of sessions. It's not going to all of a sudden decrease. The total number of sessions goes up. So the way the rate works for a counter is a little bit different. So that's why we separated them rather than saying, yeah, everything is a gauge. And we can give better statistics on a counter than a gauge. And the last two are availability. And again, this comes from the operational side of things. A resource, the availability of a resource, is a server up, down, or unknown. And here I have an example. For example, one of the servers is up for a certain amount of time, then goes down, then goes up. And you can compute very interesting stats based on that. What's the percentage of uptime? What's the ratio of down? How many times did I go down in 24 hours? And the last one is string. And there are a few possible uses. This is the one that we added the latest in the set of metrics, probably a year ago. And one of the first things that we've seen it being used is for configuration. What's the value of a key at a certain point in time? Events also, it's another good example. Now I'm going to go into like a complicated picture. No, don't get scared, I will walk this picture back. But this is what you can do today with Hawkular Metrics. This is everything that, and there is stuff that I missed. I had to revise this about 20 times since Monday, because there are constantly more and more integrations coming on board. And they all go around this central idea of Hawkular Metrics, the analytics and metrics engine, and the storage. And everything here at the periphery, they are integrations. Some of them are done by us, some of them are done by the community. So, for example, the Drop Wizard was a pure community effort. And we just said, okay, that's cool, let's bring it in. So now let's walk backwards into the architecture, because then I can talk about some of the design decisions, why we think our architecture is better than others, and why I think this is a nice setup. As I said, we picked Cassandra as the storage engine, and we went through a very complicated process. We just didn't go, let's pick Cassandra. We had an initial cut of like 20 storage engines, including Postgres and MySQL, and we narrowed it down over the course of like 6 months. It was a brutal process internally at RedHat. We had many reviews and we were challenged constantly. The decision itself was challenged constantly. Why do you need another storage engine? Why do you need another storage engine? And over the course of 5 years, we are very confident that we made the best decision. Cassandra itself is highly available and fault tolerant, and that's what we want. And it doesn't have any specialized nodes. So node 2 goes down, not a problem. We have 99 more nodes, and I don't have to know what are the roles. And there is minimal configuration. Of course, you optimize the configuration when we deploy it, or when we tell you to deploy it. But beyond that, there is no configuration required. You know, there is no let's make this node be the coordinator or anything like that. And in terms of performance and scalability, Cassandra is optimized for writes, and that's what we wanted. We wanted something to write as fast as possible, because typically metric data is only relevant when stuff goes down. If your systems are up and humming along, then metric data is not relevant, right? You don't care if the CPU is 50% for the past year. You care when the CPU usage goes to 0 or to 100, right? And it has data compression by default, and then the indexing was amazing. And these are the features that we use. There are many solutions that try to use Cassandra. From the beginning, in 2013, we said we are going to be SQL-based. And that was another controversial decision, because at that point, the Thrift protocol was the default protocol for Cassandra. So we made this controversial decision, and we kept with it, and we said, no, this is the right decision. And it just got validated about 6 months ago when Cassandra rewrote, the Cassandra community rewrote the storage engine to be SQL friendly. They deprecated Thrift. Thrift is not going to be available, and now the storage engine is SQL based. So that validated our decision. We use the partitioning and indexing in Cassandra based on how the data is used. So the time is important, the metric name is important, and a few other things. And as I said, we use the built-in compression. The metric data is very, how do you say that? It's very boring, right? So you apply compression to that, and all of a sudden you can store millions of data points in just 1 gigabyte of data. And we also use the TTL from Cassandra. We don't go and purge the data ourselves. We let Cassandra manage that. We use the data stacks driver, fully async. Is the TTL configurable? Yes. You can configure it per metric, per tenant. I don't think you can do per data point, but tenant and metric, you can go in and say, I want this data to be persisted for a month or 365 days. We start with TTL of 7, that's the default, but you can change that default of the system. We start with the default of 7 because when you think about monitoring a server, 7 days worth of data is good for short-term prediction for anomalies. The data stacks driver, again, we are one of the first users and another controversial decision starting to use that. So this project had a lot of controversial decisions along the way, and every time we got challenged, and we got challenged for the good reasons, and in time our assumptions and our decisions have been validated. So we are using the data stacks driver fully async. There is no blocking anywhere. And we try to keep up with because we are on SQL, we can keep up with the latest Cassandra revision, right? So the latest stable Cassandra release is 3.0. As soon as 4 is out, we can migrate to that. Not a problem. And one of the things that we do different than maybe other solutions based on Cassandra, we use multiple tables for indexing based on usage. So if you think about tags, tagging is important in the context of metrics. Rather than using a single data structure, we have multiple data structures that deal with tagging and storing the tags and querying those based on those tags. Now we are moving back in this picture. We are here in the Cassandra. We are going to move a little bit backwards. We are going to move in the app layer. Right now, we have a REST API with JSON only, and JAX-RS 2.0. We selected JAX-RS 2.0 because it's async. We don't want blocking stuff, and this is not your 2000 Java. We use the async in JAX-RS. We have in the middle RX Java, reactive Java, async stuff completely, and then we have an adapter that goes to the Cassandra driver, async. So our entire stack is async. We do not have any sync code. The servers, so here you can cluster, I have a picture because you can cluster those servers. The servers themselves are stateless, but there is a little bit of communication that is required. What's stateless is the idea of like querying and inserting data. You don't need to keep state. You just have a new data point, it just goes through Cassandra. But you need a little bit of state for alerting and for coordinating the schema management. If you have 10 servers going up at the same time, you don't want to destroy the schema. And we try to make it as easy as possible to use. We package it with Wildfly, and all what you need is a JDK. You just run, download, and run, and you are in business. Nothing more than that. Here is some performance sample. They were taken about 6 months ago. We go through a rigorous process. We try not to go back. Once we set up a benchmark, we do not allow commits that take us back unless it's justified. And in the past 2 years, we increased the performance, but we never went back. And these are always performance testing is misleading. The reason why I put this here, I wanted to show what you can do with a single node of Hawkular Metrics and alerting and a single node of Cassandra. And this is the testing is done in Docker, is a virtualized environment, so of course you have some inefficiency storing the data, and there is some processing, some threading issues, and these compete for the same CPUs. But it's important to see the performance at this level. If this is horrible, then there is no point in trying to do something fancy. If this is good, then it's going to work even better when you go to dedicated hardware. You can batch. We have APIs that allow you to batch multiple matrix data points at the same time. And you can see that the sweet spot is somewhere here when you go between 100 data points per request and 5,000. And this is a single Hawkular with a single Cassandra communicating. And we double here the CPUs, and we double the memory a little bit for Cassandra, and all of a sudden we almost doubled the throughput. And again, this is virtualized, it's not it's not bare metal. These numbers are better now. I just didn't have them available in this format. Some of the features for Hawkular Metrics, everything is multi-tenant. We require you to send the tenant ID on every single request, and you cannot query multiple tenants. Because you can run in an environment where you have multiple, for example, in Amazon, in AWS, you can run multiple environments at the same time. You would select a tenant per environment. And the data gets stored on this sort of in the same place, but we never allow the commingling of tenants. You can never go and say, well, I want this metric from this tenant and this metric from this other tenant. And that's part of one of the decisions that we made to have a simple security model in the beginning and see how it gets adopted, and we can branch from here. You can insert data without pre-creating the metric. So you don't have to say, well, I'm going to send you a gauge right now. You can just send the metric data and it gets stored. And later you say, well, I want to actually tag this metric. You can go back and create the metric and tag the metric. Data is compressed 2 levels. First one is done by Cassandra with LZ4. And then on top of that, every 2 hours, we take all the data from a metric and recompress it using Gorilla compression it was a paper published by Facebook. So you get that compression twice. The advantage is the data that is hot the past 2 hours, you always have it available uncompressed, so you do not have to spin CPU to actually see what the data is. And then all the data past 2 hours is efficiently stored. And when you need it, you can always retrieve it. And again, from a test about 6 months ago, we ended up, after we implemented this, 83 million data points for 1 gigabyte of disk, which is impressive. Before that, I think it was 5, 6 times, 7 times more. And once we applied this double compression, we started seeing the disk being more stable. And we still use Cassandra mechanisms for clearing space and deleting metrics. It's just on top of that we added this double compression. A few other features. We have the bulk insertion. You can send multiple metrics and multiple data points at the same time. You've seen here that the test we have 5,000 data points at once. We have tagging support for both metrics and single data points. And a tag is a key value pair. Tag 1 equals D, and you can have tag D, tag 2 equals B, and so on. And we have what's called a tag query language, where you can actually query those metrics after you insert them based on a simple expression. So for example, I have here an example, if tag A1 equals D, or A1 is not AB, and tag C is defined. So we try to make this as simple as possible to go back and query your data. And where this becomes relevant is in a cloud environment where you have multiple servers at the same time. You want to query the entire cluster at once. You want to get all the CPUs from all your nodes inside the particular cluster. This is the REST API. There's an endpoint for each metric type, so you can just go send them all in. You can access the raw data, so you send raw data and you can access that, but you can also we do query time aggregation. And I'll go in a second on what the query time aggregation is. So if you want statistics, we also have an endpoint for that. And then, of course, there are the bulk operations. You want to send 3 gauges and 5 availabilities and 3 counters. We support that. Everything is structured, clear. There are no surprises, we hope. 2 interesting features, aggregation and rates. With aggregation, you can combine multiple metrics at the same time and get statistical data. We do that for gauge encounters. You have the average, median, percentile, and you can select what percentile to get, 99, 98, whatever, and the sum. And it can be done, first we slice the data, and then we group it, and then we give you statistics for every single group. And it can be done in 2 ways. You can either look at the data as coming from a single source, and then you compute stats on that, or you can compute stats on you combine 6 metrics, you compute stats on those, and then you stack those up. Availability is a bit different. As I said, we can do uptime ratio or downtime or the duration of a downtime. We do not have yet, it's out of the slide, but we do not have stats for strings. We just didn't get a request for that. We put it out in the wild and nobody said, well, I want to aggregate strings right now. And the other interesting part is the rate. Is available for gauges and counters, and is the rate of change of the value. So for example, how fast is the total number of requests increasing? And we support reset. So you get the total number of requests to 1 million, and then you reset the server, the total number of requests is now 0. That's okay, we have support for that, so we're not going to confuse you with the rate. That's about it for metrics. Any questions about the features? Anything to go into before I jump into alerting? Okay. So as I said, last year in October, we said, well, forget about having to deploy metrics and having to deploy alerting. Why don't we mix the two? And this is in one of these boxes that I had here. So if we take one of these boxes here, that's what you get. You get a deployment of metrics and a deployment of alerting. And then you have what is called a alerter, a metrics alerter. And I'll show you in a second what's that. And then, of course, in the alerting, you can have multiple senders. You can get notification by email or SMS or whatever you decide to do. It was a natural fit because, collecting metrics is not good unless you can alert on those metrics. And there are two ways to alert on these metrics. You either use a dedicated API for alerting, and you say, well, I want to know if the CPU goes above 95%. I want you to notify me. And the way the data goes, when the CPU comes into metrics, the CPU utilization comes into metrics, we know that you are actively watching the CPU utilization and we forward that to alerting. And that gets fed into the alerting engine, and the alerting engine is going to say, well, what are the conditions, and do I need to do anything with that data, and send a notification. If you are not sure what to do, then you can use the metrics alerter, where you say, well, I'm just looking globally for the average of the CPU utilization for all the server for the past hours. Data doesn't come in if you look for the past hours, right? Data is already in, is already persisted. So in that case, you want to have a component to actually query metrics and say, give me the stats for the CPU for the past 4 hours, and then I'm going to match them. Once I have that, I'm going to feed that into the alerting engine. So there are two ways you can do this. We think it's clever. Rather than always depending on data that gets fed, we want to actually be able to recognize patterns in data that is already persisted. And of course, both of them, both metrics and alerting, they communicate with the Cassandra cluster. So not only we have the metrics stored in Cassandra, we do not require a secondary engine for the alerting portion. Here are some of the alerting features. I'm not going to, briefly, I'm going to go over this. If you have some questions, feel free to ask. So we have single or group triggers. That means you can trigger based on a single metric or multiple metrics, and you can also have template triggers. For example, I want to create a trigger every time a new CPU metric gets persisted. So rather than knowing ahead of time what kind of metric you are going to watch, you can say, well, I'm going to create this template trigger, and every time I get a new CPU type metric, then I'm just going to trigger on that. And inside those, there are complex conditions, and also there is support for dampening. Don't fire this alert more than 6 times because it's useless. You fire this alert 5 times, now have a quiet period of an hour because we don't need that. And there is also auto-resolve and auto-disable triggers. The CPU spiked to 95%. You get a bunch of alerts, but the CPU goes to 80%. There is no point in keep on alerting on that. And the notifiers here are pluggable. We support a few basic ones right now. SMS, email. There are a few, I think Elasticsearch. There are a few of them, but it's very easy to extend them. So now going back to this picture, the fancy picture that I had at the beginning. So we talked about Cassandra. That's the storage. We talked about the app layer. That's where the computation happens. And now are the consumers. We have custom libraries for Python, Java, Go, and Ruby, and you can always use curl. And there are people that use those to build their own clients. And today I'm going to actually use the Python client to create a custom agent. We are integrated with Hipster. I don't know if you know Hipster, but Kubernetes is using Hipster to monitor the pods that get deployed. Since we are in OpenShift 3 origin, we integrate with Kubernetes in OpenShift to actually collect metrics. So every time you use OpenShift, you use metrics. There is a flow that goes from Kubernetes into Hipster, into metrics, and that's where the metrics get persisted. And we also have a Grafana plugin for visualization, so I'm going to use that in my demo. Here is the roadmap for 2017. We always, at the beginning of the year, the team always shuts down for a week and we come up with a roadmap. Automatic and persistent aggregation. I told you we have query time aggregation. This does not get persisted. You query it, you see the result, it's over. When we created Hawkular Metrics and we got our ticketing system, we store tickets in Jira, the first item was aggregation. And we had this item open for about 3 years. And we could have implemented this many times. What we noticed is if we make the query time aggregation fast and meaningful, there is no point in going and storing these aggregates. There is no point in storing those persistent aggregates. It's just one more thing that needs to happen in the system, and there is very little value because most of the time you're interested in the data for the past hour, and you can cover that with alerting. And beyond the past hour, when are you interested in the data? When something goes really bad. Well, that's still an open issue. We are working on that. We want to do it properly. We want to do it in a way that doesn't require a lot of configuration from the user. We are working on management capabilities for the cluster. Right now, I have this picture like this on purpose with two entities because we do not do management of the Cassandra cluster. We have some guidelines on what you need to do. There is no direct management. And we didn't want to have the direct management because there are many usage patterns. Maybe you want to have a replication factor of 3 because of your environment requirements. But we are moving in that direction. We want to add some management capabilities to say, well, we kind of want a minimum replication factor of 3. One thing that we said we need a query language. We already delivered. This was done in February, this roadmap. We already delivered on half of that with the tag query language. But we want to continue with that, to have a query language for the aggregation, the just-in-time aggregation, and even for the raw data, we want to have a query language. And of course, there is always performance improvements. I think we think we have a good baseline, but I think we can do even better. Any questions before I go into the demo? Okay. So it's a very simple demo. I'm going to install Cassandra with CCM, local node. I'm going to download Hawkular Metrics. I have it here. I'm going to start it. I'm going to download and install Grafana. And I'm going to download and configure the Hawkular plugin for Grafana. And I'm just going to select the tenant ID. And then I'm going to install the Python client for Hawkular. And then PS utils to actually get some CPU stats. And with those two, with the CPU, PS utils, and the Hawkular client, I'm going to create a custom agent. I'm just going to collect CPU metrics every 10 seconds. And this is the Python script, and that's one of the things we constantly try to do, make the interface as simple as possible. So all what you have to do is to import the Hawkular Metrics library into your Python script, create a client, and this is the only call that I have 2 calls to Hawkular. One is right here. One is right here, create a metric definition. The only reason why I'm creating the metric definition is to tag it. I want to tag it with CPU. So CPU is CPU1. I'm just going to tag it so I can query it later. And then the second call to Hawkular is to just push that data into Hawkular. I have a machine that's already prepared with all this. So first step was configuring Cassandra. I already have it configured, so I'm going to start it. Cassandra is started. I'm going to start Hawkular Metrics. I skipped the download because I don't want to use the bandwidth. So we skip the download, but beyond the download, this is all what you need to do. And now I'm going to start Grafana. As soon as, okay, let's wait a few more minutes for this to start. I'm sorry? I don't know. It's a virtual environment. It's in VirtualBox, so probably that's what it is. I have no idea. Now I'm going to start the script that I just showed you. And you can see I'm collecting CPU stats. Yeah, I'm going to switch. Sure, yeah. So now I'm going to switch to the browser. Wow, this is... I have no idea. How can I increase this? I don't know. I don't know what's going on. Okay. And you can see that the data is streaming right now into Hawkular Metrics. So what's happening here, it's on this side of the graph. Let's see if I can go to last 5 minutes. Let's try. Oh, there we go. So now I'm feeding data from that small script that I just showed you. Let me show you the script again. So it's a very simple script. Wow. Sorry, I'm really sorry about it.
Is your screen flashing too?
Yeah, it's all my screen is flashing too. I'm done. So this is a very simple script, right? I'm just shoving CPU metrics, the value of the CPU utilization into Hawkular Metrics. Very simple. I open the client, I select the tenant ID, that's important. I just select the test, you can select the host name. And I'm just pre-creating that for the tags. So we can have some tags, we can say, well, those are CPUs. The tags are right over here, right? The CPU, it's a CPU tag, and the CPU ID is the tag value. And every 10 seconds, I'm just collecting this data. And then it goes on Grafana. Now I have more data. Very, very simple demo. It's just the idea is to showcase that our mission is to be the core, the invisible core here. We want to be the invisible core that just collects the metrics. You don't have to worry about the metric collection. You don't have to worry about querying that. We wrote the plugin for Grafana. We have the client, the custom client. All what you have to do is to use a few lines of code, and then we just forget about this. Go ahead. Yeah.
Can you show how you configure Percona to like
Yeah, it's a plugin, and you just download the plugin, and then you say use this tenant ID. You add another data source. It's flashing a lot, so I hope nobody's going to get a seizure. I'm sorry. So you go here, data sources, and I already pre-configured the Hawkular Metrics. So what you have to say, what is your host? And then this is direct access. If you are in OpenShift, then you use a different one. It's a proxy. And then there is authentication and credentials and all that. But right now I'm just using a simple thing. It's based on the tenant. And I have here the tenant. That's all what you have to do.
Should be a local metric for that tenant.
No, you go into actually the dashboard. Yeah, you create another dashboard. I just put a CPU here, but you can create a dashboard for memory. You can create a dashboard for other things, network traffic. In OpenShift, right now we collect a lot of metrics. The memory and the CPU are displayed when you go and look at the OpenShift console. The memory and the CPU usage, and I think the network traffic is displayed inside of OpenShift. Right. The UI for OpenShift Origin, yes. Yes. Yeah. If you get OpenShift Enterprise, you get metrics. You just have to enable it. Yeah. Right. Hawkular Metrics and Hawkular Alerts are in there. And what's interesting, now if you want to develop something else on top of that, you can get access to Hawkular Metrics and alerting deployed inside of OpenShift. And the metrics are going in there from OpenShift. And you can also either probe them or add your metrics in there. That was a heavy demo. I didn't want to do that demo here to start an entire OpenShift cluster and then show you like one thing in the UI. It's sort of the same. Let's see if I can go to this. Any more questions? Anything else? So I went through the demo. I will have this presentation available if you want to try this. I have a bunch of resources here. And if you want to contribute, I mean, my goal for today was to get at least one post-conference interaction. So, I would love to talk to you after the conference. That was my ultimate goal, one post-conference integration. The reason I said earlier, we try to be as invisible as possible rather than being upfront and say, well, you're using metrics. We try to be invisible because metrics collection, if it doesn't work, is broken, right? If you constantly have to tweak it, then something is wrong in here. So that's why one of the biggest deployments is with OpenShift, and we try to serve those customers as good as we can. Customers, users, community members. Any other questions? Anything else to Hawkular.org, where all of us are on Freenode.
In your demo, where you have a single standard node and a single Hawkular node, do you ever do any benchmarking with multiple scaling that out?
Yeah, it's not linear. Linear means, I think it's more like this, more log, is not linear. It totally depends on your network and on your I/O. The reason why my metrics are like this, we constantly do benchmarking. The reason why I selected these numbers is to showcase that with a restricted access to resources and disk, we still get amazing numbers. So first of all, if you put on dedicated hardware, you're going to get much better numbers. And if each one of those is on dedicated hardware, then you're going to get much better numbers, right? So the numbers improve as you improve the scenario. Right now, they're both collocated, and we just try to shovel as much as we can in these. You split those apart, dedicated hardware, you're going to increase that, and then when you add more, the expectation is you're going to grow your Cassandra cluster first, and then have to grow Hawkular Metrics, the app layer. That's how we plan. That's how we design the schema. First you grow Cassandra, and then the ratio maybe 1 to 5, 1 to 6, and then you start growing your Hawkular Metrics. Cool. Any more questions? Okay, thank you very much.